So the second anchor chart, now that we've got our definitions of our three types of sides, we're ready to talk about some things called the trig functions. Okay, so let's just redraw the diagram that we had before. Okay. Actually, just to make things a little bit more interesting, let's do a triangle that's a bit tall and skinny. Okay, just to show you that the same logic applies with the definitions. So we got our theta here. Over here we've got the opposite side. Down here we've got the adjacent side. Okay, and then we've got the hypotenuse. Okay. Now one thing that's kind of interesting, all right, if you take the angle theta, right, and you just draw some right triangle along it. So it could be the one that we've already drawn. It could be one that extends, okay, even further. Okay, but if you draw any right triangle with the angle that shares this angle theta, all those right triangles are going to be similar. Okay, why are they going to be similar? See if you can tell. Okay, the reason why, we've got two angles that are the same, right? So both the big yellow triangle and the black triangle, right? They both have a 90-degree angle and they both have theta in them, okay? So all the angles that you draw that share this one angle, all the right triangles are going to be similar. And so that means that you get this nice property where the ratios of the sides don't depend on how long the right triangle's legs or hypotenuse are. They just depend on the angle. Okay, so we'll see what that means in a bit, but we can write some new notation. So sine of theta. Okay. Okay. Sine of theta is equal to the opposite side divided by the hypotenuse. Okay. And this is, the full name is the sine. Okay. So it's not called the sin, it's called the sine. Similarly, the cosine of theta that's equal to the length of the adjacent side divided by the hypotenuse. Okay. And again, the full name of that is the cosine. Okay, it's not cos, it's not cos, it's the cosine. And then the tangent of theta is equal to the opposite side divided by the adjacent side. Okay. tangent. Okay, it's not called the tan of theta, although it's written that way because it would take a long time to write this, but it's called the tangent of theta. And here's what's kind of useful but surprising. Okay. Useful but surprising. These functions, their values, they depend only on the angle theta. Pretty cool. And you might be wondering why. Why is that? It's for the same reason that a line has a constant slope no matter how big you draw the slope triangle. And it's also because of the similarity fact that I talked about earlier. Okay. This is kind of something that you just have to see in practice. And so as we move through with the week, you'll get some practice with the trig functions, and you'll kind of get to see like, hey, if you got the same angle, turns out that these functions don't change no matter how large the sides of the triangle that you use. Oh, one more thing that I forgot to mention. Many people find it helpful to use the memorization tool, the mnemonic, SOHCAHTOA. Okay, so SOHCAHTOA, as in sine is opposite over hypotenuse, or so, right? SOH, so. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. Toa, SOHCAHTOA. Okay. So if you find that helpful to remember which trig function is which, then feel free to use it. Again, SOHCAHTOA. All right. That's it.